All right, let's go through some answers. Where's my pen? There it is. There's two. There's two questions for each of these. I will. Let's see. I'm going to show you this. Yeah. There it is. Okay. I don't know if this is the class that I said this in, but don't judge me for my tabs. It helps me stay organized. Okay. So for each of these, there's two questions. You were assigned one of them at random, and so we're going to go through them and just take a look at each one. You got feedback on your individual questions, but the feedback I gave you, it might make sense if you're really deep into the calculations. You know exactly where it went wrong when I tell you what went wrong. And for some of you that aren't as deep into it, you'll be like, well, okay, that's great, Dr. Bowden. I don't know what you're talking about. So putting your comments that I left for you on each question together with this should help you figure out what you need to do. Going through this and looking at your answers that you turned in should help you for the next exam because that also has mathematical calculations, not the same ones, but related ones. And then also the cumulative final does have all these kinds of related questions. So it's not a bad idea to at least just follow along with the ones that you got and see where you went wrong. Okay. So question one was this one about a mass spring system. It has a resonant frequency of 300. In both cases, what's the resonant frequency if, and then we've got stiffness is increased, then resonant frequency is increased, and then mass is increased. So the first thing that we're going to do is, what is our formula for a mass spring system, right? And so the formula is, we've got the resonant frequency equals 1/2 pi times the square root of k over m. You're given the resonant frequency. In both cases, it's 300. So we can just get rid of this and put this in as 300. So first one, let's go back. Okay, stiffness is increased by 81, resonant frequency is increased by 6, and mass is increased by a factor of 25. So, back over. K is increased by a factor of 81. The resonant frequency is increased by a factor of 6, and mass is increased by a factor of 25. Is that what I said? Yes. No? Yes. Yes. Okay. So, if K is increased by a factor of 81, we've got up here 81K. And that means really all we need to do is figure out what the square root of 81 is, which of course is 9. And what's going on here is 9 is just going to be multiplied by everything else here. And that means it's going to increase this. So you're just going to do 9 times 300 equals 2700 hertz. So that's what happens when stiffness is increased by a factor of 81. The next thing that we're going to do is resonant frequency is increased by 6, a factor of 6. What is your resonant frequency? This is your resonant frequency. Resonant frequency is increased by a factor of 6? Well, that just means 300 times 6. That is like literally the whole question right there. Real simple. It's 1800 hertz. So that's the answer for that one. Okay, we'll get rid of the rest of this. And the last one is mass is increased by a factor of 25, so we've got 25 m here. So this is similar to 81K. What we're going to do is we're going to figure out what, now remember, when it's on the bottom, when 25 is on the bottom, a lot of errors that I saw was that you are multiplying by 5. So you knew that you needed to take the square root of 25, but you just multiplied 300 by 5. You can't do that because what's actually going on here is it's still on the bottom of this division. It's still the denominator. So you can think about this as 1 over 25 instead of just k over 25m. Think about it as 1 over 25. So if you're going to take the square root, well, let's not do a square root in a square root. That's going to get confusing. But if you're going to do the square root of 1 and you're going to do the square root of 25, then you've still got the square root of 1 is 1. And the square root of 25 is 5. So you've got 1 over 5 is what you're multiplying by 3. The other way that you could say 300 times 1 over 5 is 300 over 5. And that's equal to 60. So the answer to all of these in order, almost everybody got this one. It's 2700. Great job. This one was a little tricky for some people. I think it's just because you were just thinking about the process. This is resonant frequency. So the answer to this one is 1800. And this one I think was the trickiest for everybody. Just because you multiplied 300 by 5, not all of you, but you know, if you made a mistake here, this is pretty much what you did. So it's not like you didn't know the process. It's good. You're very close to what it is. You just multiplied instead of dividing. You didn't lose a ton of points for that because you were very close, but this one is 60 instead of, what were you guys getting? 1500, I think. Okay, so that is one version of this question. Let's go through and do the second version of this question. Okay, so what's cool is, I don't know if you can see this, but the faster I move the pen, the larger the eraser gets, which is awesome. I just can't move fast enough to make it as big as I want it to be, I guess. Okay. So the other question was stiffness is increased by a factor of 49, resonant frequency is increased by 12, and mass is increased by 4. So stiffness is increased by 49, factor of 49. Resonant frequency is increased by a factor of 12. Mass is increased by a factor of 4. Okay, so same deal here with K. Stiffness is up here, so really what you are looking for, this is like 49K. So you take the square root of 49, which is of course 7. That, man. There we go. Square root of 49 equals 7. So you're just going to multiply 300 by 7 and end up with 2100. Oh, that's my... Okay, that's great. You're going to see all the notifications from my textbook publishing company. Didn't plan on that. Next thing is resonant frequency is increased by 12. I think this is where some of you were a little confused, and the reason for that is, let me get rid of this. There we go. The reason for that is you're looking for stiffness is up here. Mass is here. And resonant frequency, it says what happens to the resonant frequency is increased by 12. Well, that's resonant frequency right there. 300 is resonant frequency. So what you have to do is 300 times 12 equals 3,600. That's the answer for that one. It's very simple. I think if you got it wrong, you're making it harder, I think, than it needed to be. And then mass increases by a factor of 4. I think this is probably the one that most people got wrong, because you knew that you had to take the square root of 4m. The problem was you multiplied by 2 instead of dividing by 2. So you can think about k over 4m as k over m times 1/4. Still under the radical there. And then the square root of 1 over 4, you can reduce that down to the square root of 1 over the square root of 4, which equals 1 over 2. So you've got 300 times 1 over 2. Another way to say that is just 300 divided by 2. That's supposed to be a 2. It looked like a weird little hat. 300 over 2, which is 150. So the answers for these are 2100 right here, 3600 right here, and 150 right here. All right. The next question is about Helmholtz resonators. So while I'm erasing this, the formula for Helmholtz resonators, think about that. Try to pull it up in your brain. If you watched my video about the beer bottle, you might know it even more by heart. But essentially it is the resonant frequency, which there's only one, because it's a Helmholtz resonator, equals C over 2 pi times the square root of A over VL. All right. So you're given, depending on your luck, you're given 2 sets of values. One isn't easier than the other, so it's not really luck. Sorry, my chair is very noisy. I don't usually move around this much when I'm on camera, but I'm not on camera, so I can just bounce around. All right, so if you are in the first group, your values were A equals 220, V equals 1400, and L equals 73. Yeah, 73. If you're in the second group, your values were A equals 290, V equals 900, and L was also 73. If you want to see this question, before we keep going, if that's going to help you kind of cue it in your memory, the question is: a Helmholtz resonator has a neck area of 220 or 290, a neck length of 73, and a bowl volume of 1400 or 900. The speed of sound in both of these is 340,000, and you're just going to compute the resonant frequency. And then draw the picture, which Lots of people missed that. So I didn't even take points off for that this time. Make sure you draw the picture on the future tests. Don't skip the drawing the picture portion. Okay, so let's solve this. Speed of sound is 340,000. Okay, so to solve for A, we're just going to set this equation up for the resonant frequency equals 340,000 over 2 pi multiplied by square root of 220 over 1400 times 73. One thing that I'm going to do at the very beginning is just rewrite this and kind of simplify some of the things that we've got here. So 340,000 over 2 pi is 170,000 over pi, and 170,000 over pi equals 54,113. So this whole thing equals 54,113 multiplied by the square root of 220 over simplified it too much. Sorry, everybody. Oh yeah, 10,222. 220, not 222. Okay, so that's where we are right now. I'm not really going to get rid of this 54,113 for a while, so I'm just going to kind of stop talking about it for a little bit. If you do that math right there, that ends up being the square root of roughly 0.002153. Which, if you take the square root of that, is roughly 0.04639. And then if you do that math right there, you end up with 2,510.64. Obviously, you probably know this from your scores. If you were close to that, you got points for it. I mean, rounding looked like it took everybody from roughly 2,400 and, man, what did I see? I think it was 98. Somebody had that, and somebody else had 2,522. So depending on how you're rounding and where you're rounding, it's somewhere around there. The amount of rounding I'm doing gets me here, but you got points if it was close to that. Okay, so let's get rid of some of this, and we're gonna do the next one. So much erasing. Oh, it's so much better. So much faster. Okay. Next. So a resonant frequency equals 340,000 over, that's a 4, by the way. 340,000 over 2 pi. Times the square root of 290 over 73 times 900. All right. 340,000 over 2 pi is the same thing as 170,000 over pi. And 170,000 over pi is 54,113. So I'm just going to leave that like that. We'll go ahead and simplify this. So 290 over 73 times 900, 65,700. And we'll just keep writing this number here, 54,113 times 290 over 65,700 equals square root of 0.004414. Oh, great. I don't have... Sorry. I didn't have the calculation for that on my answer sheet that I wrote out. Okay. So the square root of that, just, sorry, before we do that, fill in 54,113. The square root of 0.004414 is 0.06644. And if you do that math, 0.06644 times 54,113, you get 3,595.16. Again, just like with the one before, this has a range of acceptable values based on rounding, but if you were close to this, you got points. So if you had, I think somebody had 3,550 was like the furthest away, and it was still right just due to rounding. So that's totally fine, no problem. But you'll know that because you got points for it. If you're computing it yourself and you didn't get this right, and you're going through and you're close, that's good. It's a rounding mistake. Okay, the next question that we're going to do is a tube that is, I think, open at both ends. That's the next one we're going to look at. And we're changing the speed of sound because we're dealing with a different measurement of length. That's the reason why the speed of sound seems to change. All right. Find the first four resonant frequencies of a tube with two open ends, a length of 0.4 meters or 0.15 meters. The speed of sound in both cases is 340 meters per second. Okay, so that's not so bad. Oh, wait a second. Draw a picture of the filter this Helmholtz resonator creates in the frequency domain. There's what you need. This is like the filter right here. This is the filter. I've got this line right here showing where it's centered. And where it's centered is either 2,510 or 3,595. Totally depending on which question you got, but the picture is going to look the same with different numbers. Don't leave that out. It's really simple, and on each of the next exams, there will be points assigned to that one because, well, just don't overlook it. That's why. Okay, next one. It's the first four resonant frequencies of a tube. So the formula for this one, I think, is one of the easiest formulas that you have to remember. It's just resonant frequency equals n times C over 2L. That's it. In this case, C equals 340. That's because we're dealing with different lengths. It's meters per second here, and we're dealing with meter. The length is in meters. When we were doing Helmholtz resonators, we were dealing with millimeter lengths, and so we're doing millimeters per second. That's why the speed of sound is different between these two kinds of calculations. I don't think anybody made a mistake and had the wrong speed of sound. So I'm not saying that because anybody did. Just to let you know that that's the difference. Okay, we have two different lengths. If you got question A, your length was 0.4, and if you got question B, your length was 0.5. 0.15, sorry. So remember the N just means which harmonic you're finding the resonant frequency for. This is not like a Helmholtz resonator. We've actually got more than one frequency that can come out. Some of you calculated the first frequency correctly, the first resonant frequency correctly, and didn't go on to do 2, 3, and 4. That's true for a Helmholtz resonator. But for a tube, which would be like, you know, your pharynx or a flute or anything like that, it definitely has harmonic overtones. So definitely have to calculate all of the harmonics here. So for 0.4, your formula looks like this. We're going to start by solving for that portion right there. 340 over 2 times 0.4 equals 340 over 0.8, which also equals 425. So now we're going to solve for our harmonics. We've got harmonic 1, harmonic 2, harmonic 3, and harmonic 4. In this case, we're just going to multiply these harmonic numbers by this that we just solved for. Well, 1 times 425 is 425. 2 times 425 is 850. 3 times 425 is 1275. And 4 times 425 is 1700. Okay, there we go. That's your answer. I did see a couple of you do something different. Oh, yes. I know what it was. So I did see a couple of you find this correctly. You got 425 correctly, and then you took 2 times 425, which is correct. You ended up with 850. And what you should have done is 3 times 425. But what you did was 3 times 850. And then you took 4 times the answer that you got from 3 times 850. So you're multiplying it by each number that you're getting. That's not what you want to do. It's integer multiples of this right here. So 1 times this, 2 times this, 3 times this, 4 times this. Always come back to this fundamental frequency right here. This is the first harmonic. This is the fundamental frequency. They're the same, but what you want to do is always multiply what the frequency that you're looking for by the fundamental frequency. Don't start thinking about it as multiply it by any of these harmonics. Just think about it as the fundamental frequency. The fundamental frequency isn't going to change. It's always 425. If you want to find the 10th harmonic, you multiply 10 by 425. Okay. Next. I should get some like very jaunty music to play while I do that thing I just did. Erase all that stuff. Okay. Let's look at question B. If you got question B, your length was 0.15. So what we're going to do first is look at just this portion right here. 340 is C. So we're going to have 340 over 2 times 0.15, which equals 340 over 0.3. What does 340 over 0.3 equal? Well, it equals 1,133.33. I'm going to go ahead and drop the decimal right now. It's fine without. It's fine with, but it's also fine without. So you're going to find now your harmonics. So 1, 2, 3, and 4. And you're just going to multiply your harmonic number, 1, 2, 3, and 4, which is this n right here, by the fundamental frequency, which we just calculated right here. So 1 times 1,133 is 1,133. Cool. Easy. It's great. 2 times 1,133 is 2,266. Great. 3 times 1,133 is 3,399. And 4 times 1,133 is 4,533. 32. Yeah. 4,532. If you rounded these, that's fine too. I definitely saw a lot of 3400s, and that's fine. Nothing wrong with that. Okay, great. Some of you, like I said in the last one, but I'm not, if you're skipping over to the ones that you got to, I'm going to say it again. What I saw a lot of was, not a lot, I saw a lot of exactly the right answer, and great job. But some of you took, to find 2, you multiplied by 1. And that's correct, because you could multiply by this one or this one, and you'd be fine. But to get 3, you multiplied by the harmonic you found for 2. And that makes it off by quite a bit. And then to find 4, you multiplied by the number that you got for 3, which makes it off by a lot. So make sure that you're always multiplying by the fundamental right here. That's the one you want to be multiplying your harmonic number by. Okay, the next question was easy for me to write because it said the tube that you just looked at has been closed at one end. So I didn't have to write 2 different questions. I could just refer back to that question. We have a new formula too, so I'm going to get rid of that. So the tube has been closed at one end. Here we go. The tube from the question above has been closed at one end. Find the first 4 resonant frequencies of this new configuration. Oh, sorry. You needed to draw the filter again. This one's pretty easy too. It's just like a few cycles of a sine wave. 4 cycles of a sine wave. 1, 2, 3. Well, it's like 3.5 cycles of a sine wave, really. No, it's 4. I wasn't looking at this side over here. Okay. So depending on what you had, you're going to draw this, and then you're going to label it differently based on what graph you had. It's either 425, 850, 1275, and 1700, or it's 1133, 2266, 3399, and 4532. There you go. There's your picture. Don't forget those. It's like easy points. All right, the tube above has been closed at one end. Find the new resonant frequencies of this configuration. You don't have to draw this one, so I'm not going to forget, and then we have to go back. We have a new formula The formula for a tube that's closed at one end is FR equals 2n minus 1 multiplied by C over 4L. C is still 340 because we're still dealing with meters, not millimeters. All right, our lengths are the same as above. We've got 0.4 and we've got 0.15, depending on who you are. Let's do the length of 0.4 first. Just like before, I'm going to solve for this portion right here first. So that's going to give me 340 over 4 times 0.4, which equals 340 over 1.6, question mark. In my voice, I went too far. I didn't show enough work to myself. Yeah, 1.6. So 340 over 1.6 is what? I do have that one here. 212.5. Okay, so now we have this portion right here. We're going to take our 1, 2, 3, and 4. Those are the harmonics we're searching for. Those you're just going to plug into that equation right there. That looks like an E. I'm going to get rid of that. We don't want an E there. 1, 2 times 1 is 2 minus 1 is 1. So our first resonant frequency is just 212.5. Our second resonant frequency is 2 times 2, which is 4, minus 1 is 3. 3 times 212.5 is 637.5. 3, the third resonant harmonic is going to be 2 times 3, which is 6, minus 1, which is 5. And 5 times 212.5 is 1062.5. And then the last one, the fourth one, is 2 times 4, which is 8, minus 1, which is 7. 7 times 212.5 is 1487.5. So there's your new harmonics, if your length was 0.4. But now let's go through and figure out if your length was 0.15. Okay, if the length is 0.5, what I'm going to solve for first is this portion right here. So we're going to have 340 over 4 times 0.15. That equals 340 over... Once again, I didn't show myself enough work when I was making the answer key. But 4 times 0.15 is 0.6. So 340 over 0.6. 340 divided by 0.6 is 566.67. Oh, let's just do 567. 567. Okay, that's our base frequency there, our fundamental frequency. So now we've got 1, 2, 3, and 4 harmonics that we're going to compute. 1, we're going to take 1 up here. 2 times 1 is 2, minus 1 is 1. And 1 times 567 is just 567. 2 times 2 is 4, minus 1 is 3. And 3 times 567 is 1701. 3 is 2 times 3 is 6, minus 1 is 5. 5 times 567 is 2,835. And then 4, 2 times 4 is 8, minus 1 is 7. 7 times 567 is 3,069. 3,969. Yep. twice. All right, there you go. That's if your length is 0.15. Then we've got one question left. Oh, we don't need any of this. It's a whole new question. The last question is, there we go. A tube with one end closed, so I actually should have left the formula that I got rid of, has a second resonant frequency of either 3187.5 or 1275, depending on which question you got. The length is increased by either a factor of 4 or 3, and what I want you to do is find the new second resonant frequency. So this, like I say here in the hint, it's going to require solving for two different tubes, basically. So it's like two questions in one. That's why it's just one question, but worth as many points as the other ones. Okay, so let's start this. Started in exactly the same way that we started the others, basically, by writing the formula out. So the resonant frequency equals 2n minus 1 times C over 4L. And in this case, C equals 340. Okay, what did I tell you? The second resonant frequency is 3187.5. 3187.5. B was 1275. Yeah. And then I think that was 4x and this is 3x. Did I get that backwards? No. All right. First step. This one I think was, if I'm going to find a question that more people got wrong, it was actually number one, because a lot of people were multiplying the mass by the resonant frequency instead of dividing. This would be the second most popular one to get wrong, but that's why you're showing your work, so I can still give you a lot of credit if there was a small mistake. So let's walk through this one. Walk through them all. That's a dumb thing to say. I'm going to solve for 1275 first. No, I'm not. Yes, I am. So we're going to solve for 1275 first. What we're going to do is 1275 equals, so you're going to set this whole portion of the equation right there equal to your second resonant frequency. So 1275 equals 2. We know n in this case. It's your second resonant frequency, so you're going to put in a 2 minus 1 multiplied by 340 over 4L. L is what we don't know. So that's what we want to find. So we know that the second resonant frequency is 1275. We know that N is 2 because it's the second resonant frequency. What we don't know is L. Okay, so let's do some math. 1275 equals, let's figure this out. 2 times 2 is 4 minus 1 is 3. So 3 times 340 over 4L. Let's get rid of that 4. 340 divided by 4 is 85. So this equals, I'm not going to do, let's make it a little bit more linear. 1275 equals 3 times 85 over L. That's an L. It doesn't look like an L, but it is. What we can do now is multiply 85 by 3, which is 255. So we can say 1275 equals 255 over L. Now we can get rid of Well, we can solve for L, basically. So what we're going to do is multiply both sides by L. So you're going to have 1275L equals 255. Why did the L go away? Because if we multiply both sides by L, then you've got L over L. They cancel each other out. And then you're just left with an L over here. Now you want to get L by itself. So you're going to divide by 1275. That doesn't look like a 1. Now it looks like a 1. That's good. Okay, so you've got 255 over 1275, and that is 255 over 1275. 0.2. So L equals 0.2. That's great, and that is not the last answer that you're going to get to. What you need to do is multiply this by a factor of 3, because now we're increasing the length of the tube. So the new length equals 0.6. And now we're going to resolve for that. For the new second frequency. The new second resonant frequency. Okay. So now we don't know this, the new second resonant frequency, but we do know the rest of the equation. So we do know 2 times 2 minus 1 times 340 over 4 times 0.6. I think I'm going to need some more space. All right. So 2 times 2 is 4 minus 1 is 3. 3 times 340 over, what is 4 times 0.6? Should be 2.4, but I am neurotic, so I'm going to double check. 2.4. 340 over 2.4. Like, we could just do that. 340 divided by 2.4 is 141. It's 142. And 3 times 142 is 426. And that's your answer. That's the second resonant frequency of the new, longer tube that's open only at one end. 426 hertz. Okay. Now for people who got question A. Oh, whoops. Well, no, I'm going to go ahead and erase that one so I have more room to work. Because that one got a little tight. Okay. If you had this question, 3187.5, we're going to do the same thing as we did before, which is we're going to set this entire equation. That's why I had that line under there. We're going to set this entire equation equal to this. And we know n because it's our second resonant frequency. So we know that we're going to set n to 2. So what you do is 3187.5 equals 2 times 2 minus 1 times 340 over 4L. L is what we don't know. We're going to be solving for L here. So we can keep going with this. 3187.5 equals 2 times 2 is 4. Minus 1 is 3. So it's going to be 3 times 340 over 4 L. Next, we've got 3,187.5 equals 3 times 85 over L. And then we can simplify that further to 3,187.5 equals 255 over L. Okay, now we're going to do a little bit of a fancy math move. We're going to multiply both sides by L. So if we multiply this side by L, those cancel. And then we're going to multiply this side by L. So we've got L times 3,187.5 equals 255. I'm going to rewrite that so you can kind of see. 3,187.5. L equals 255. And what I'm going to do now is divide both sides by 3,187.5. To find that L equals 0.08. Okay, that's not your answer. Not yet. It's like the first answer of this two-part question. What you have to do now is you have to multiply the new L equals the old L, which is 0.08 times 4. 0.08 times 4 is 0.32. So now we know that L equals 0.32. Now we can figure the new second resonant frequency. So we're going to do exactly what we did before. We're going to say FR equals, because we don't know the new second resonant frequency yet, but we do know that it is the second resonant frequency. So we're going to put 2 times 2 minus 1 multiplied by 340 over 4 times 0.32. Sorry, I was looking at my stupid notification again. Sorry, you have to keep reading those. We're going to reduce this to 3 times 340. 4 times 0.32 is 1.28. And 340 divided by 1.28 is 266. So we come down to 3 times 266, and that's going to give us 797, 798. Don't do it in your head. Okay, 798. That's your final answer right there. That's the second resonant frequency of the longer tube. Quite a few steps to get there, but it's just using the same frequencies you know and applying your knowledge of what, like the resonant frequency is and the length. Okay, those are the answers to your quiz, your exam rather, to the hand calculation part of your exam. If you'd like to see the answers to the multiple choice, that should be locked so you can't see it. But you can make an office hours appointment with me, and I would be happy to go over those with you. Okay. I will see you in another video at some point. And now you get to watch me go over here and click stop.